We have two goals: to participate to collective awareness concerning this marine debris pollution, and also to contribute to the scientific knowledge of this pollution, mainly by giving or producing data concerning the microplastic pollution on the sea surface layers. So we have a small boat, 10 meters boat. We make some expeditions with this boat. We have some collecting tools. You see here what we call the montage roll. It's a system to collect the water samples. It's just a metallic structure with a plankton net on this structure, and you filter the water to collect these microplastic elements. And then we work with academic institutes, so here the Swiss Federal Institute of Technology, to analyze these samples and to produce these informations, this data, and we provide now this data to the United Nations Environment Programme. On this map you see the different samples we collected, so each point is a sample going from white to red. Red, of course, is a more polluted site. The green one are the samples we collected but that are still not analyzed. We're working on it. And we did this during 4 years. And we realized it's a huge work because you have to do expedition, do fundraising, do science in labs, find volunteers. It's extremely heavy, long. Even if we are really passionate, it was still complicated. So now we decided to change our way to work, and we don't go at sea anymore. We work with collaborations, and we have different boats that are sailing around the world, and they collect for us these samples. So we have one boat from the Fondation Pacifique, so it's also an organization from Geneva. They sail around the world. We have a boat in the Arctic and two in the Mediterranean Sea. That's for Oceaneye. So let's just come quickly to the basics. So we produce around 300 millions of tons of plastic every year. A part of these are lost in the oceans. We think the flow rate is about 10. My colleagues thought about 6 million tons per year. And we think the plastic, the quantity of plastic in the oceans is between 100 to 200 millions of tons. And we differentiate 3 study zones. The first is the seashore. It's where we see the plastic, but it's only a small quantity of plastic that we found on the seashore. If we face these two numbers, we see there is a small problem, because we think there are 3 millions of tons of plastic going in or floating plastic going in the ocean every year, but we measure only 250,000 tons in the oceans. So the question, of course, is where is all this floating plastic going? So there are different reasons maybe why we don't see all this plastic. Maybe we don't have enough data. We have local sampling to see to have a global view of this pollution, so maybe we don't have enough data. Maybe we understand or we ignore some physical phenomena, or maybe we don't measure the plastic at the right place. We don't know. So there are different hypotheses. One could be that they are in the stomach of the fishes, we don't know. Another, I would say the hypothesis that is mainly proposed in the same scientific publications is that there is this organism who fix on this plastic and who produces these biofilms. They have density higher than seawater. At the end, these floating particles, they sink. And an alternative hypothesis is, of course, that this fragmentation process continues until to a smaller size that the mesh we use to filter the water to collect these samples. This seems quite logical. So there is, physically, I think there is no physical limitation to the size of these particles. So they could be extremely small, maybe the size of the micron, we don't know. And if you do really basic physics, you will see that the rise speed of a particle is reducing with the size of the particle. You can do a simple experience. If we drink a sparkling water, you will see that the small bubbles, they go up at a speed really reduced in comparison with the big bubbles. Okay, so for example, we work with particles with the size of around 1 millimeters, and the rise speed is 1 millimeter per second. So it means if you do this particle in the water, after some hours, it goes up of some meters. But a particle of the size of the micron, the speed would be about 1 nanometers per second. So this is quite zero. These particles, they don't float anymore. They don't sink, but they don't float. Maybe they're just into these two waters. So this changed a bit the situation because it means that these particles, they are only under the effect of the sea currents, the upwelling, the downwelling, and they could pollute not only the sea surface, but the whole water column of the oceans. So it means that we don't have only these three study zones, the sea floor, the seabed, and the sea surface, sorry, the sea floor and the seashore, but also the whole water column. Okay, so this is one point of view, and arrive at the last point of my presentation. For me, this gives us an indication that we need more data. We do not understand the general transportation of this plastic, and we need more data in different regions, in different depth, in different sizes of particle. And why do we have so limited data? Because it's complicated to go with a boat in this region. We saw there are some expeditions, the Tara expedition, we do, the American, the French, different people are doing, but we have limited quantities of data. And the lab analyses are quite long for the moment. We have to improve these methodologies. So the solution, that's why we try to do for the moment, is the option one, is to be more efficient, to use this network of boats, and to improve the sampling, and to simplify the process of analysis of the sample, to produce more data. In the future, we can imagine this approach has still strong limits. We can suppose that in the future, if we want to really understand what's happening, we need new tools, more powerful tools, which allows us to have this data in huge quantities, and why not to, for example, equip different boats that are during their navigation, when they cross the ocean, could collect the sample for us. It could be cargo ships, it could be ferry ships, research ships, sailing ships, or ROVs, marine gliders, or different tools. And the basic idea, is to develop a microplastic detection system. So today we know in the water it's totally possible to detect an object. That's not a problem. The most challenging part in this idea is to differentiate the objects. Differentiate, because in the water you don't have only plastic. You saw you have plankton, you have bubbles, you have a lot of things, and how to differentiate these different elements. And we started a project now with the Swiss Institute of Technology in this to try to see if there could be an idea to develop such a tool, because it would be extremely helpful, and we did some basic tests in lab, polluting water with microplastic and testing different tools to see if we see this microplastic. So the goal would be at the end to develop a network of boats collecting the samples to have a better global understanding of this pollution. So I arrived at the end of the presentation. Thank you for your attention. And